Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 030. This lecture video is in regards to Module 3, Section 5, dealing with length, both with U.S. standard measurement and metric system. I wanted to first show you guys the conversion sheet that's on Moodle. I highly recommend using this. Basically, I took all of the conversions that you're going to use throughout the entire module from the textbook and put them on one document, just so that it's easy for you to have them all in one place, and you don't have to flip through all the pages in the book to constantly find conversions as you're working through problems in the module. So we are going to look at length today. So we're actually going to be looking at standard or U.S. measurement length. So that's this column over here. Notice I've broken this up on the conversion sheet so it's easy for you to find conversions. This top part is standard U.S. You've got length, weight, capacity. We're going to look at length today. We'll deal with weight and capacity later. And then in the middle, you've got metric, and we're going to be dealing with length with metric system, and that is going to be the middle row, which is meters. And we'll talk about that, how to use that here in just a minute. And then the bottom part is conversions between US and metric. So if I'm going from inches to meters, for instance, or vice versa, that's how we can go back and forth from US to metric in all three categories: length, weight, and capacity. We'll work with that part of the conversion sheet in a later section. So you're not going to use all of this at one time. Well, you will eventually once you get to the post-test, but today we're just going to look at length. So, all right, so I've picked out some examples similar to your homework problems to do, so that we can then identify how to work through these problems so you can be successful on the homework. So the first one says convert the following measurements, and I've just got a whole plethora of examples here. The first one says convert 12 yards to feet. Okay, so we are going to work through these conversions using unit fractions, and that's generally the way that conversions are taught throughout the module in this course and of course other courses. So the first thing that you want to do if you're doing unit fractions is to list the units that you're given. So in this case, 12 yards. And I highly encourage you to label the units. So make sure that you put the yards here. If you just put a 12, that doesn't really help us any. The units are just as important or more important than the numbers in these problems. Okay. So then we're going to multiply this fraction, 12 yards, and if I want to write this as a fraction over 1, I can, if that helps you, times the conversion factor as a unit fraction. So if I look at my piece of paper here for length, all right, I have a conversion from feet to yards, which is right here. 3 feet equals 1 yard. So I want to write that as a unit fraction, and I want to write it so that yards cancels, and I'm essentially left with feet in my answer because that's what I'm wanting to convert it to. Let me zoom out a little bit here. Okay. So in order for yards to cancel, I need to put yards down here in the denominator of this fraction, so that yards is in the numerator of this one, yards is in the denominator of the second fraction, and so yards cancels, and I'm left with feet. And so feet goes in the numerator here. So this is what we call a unit fraction because it's essentially equivalent to 1. 3 feet equals 1 yard. So this is equal to 1 but it allows us to cancel the units of yards. Yards cancels, right? Because I've got yards in top and bottom, and I'm left with feet. Okay, and then from here I essentially just multiply the two fractions. So 12 times 3 is 36, and 1 times 1 is 1. 36 over 1 is 36. So if we wanted to use a unit fraction to do this conversion, that's the method that we would use. Now some of you guys may be watching this and you're thinking, well, I don't need to do all that work. I just know that I basically multiply 12 times 3, and that's fine. If you can work through that in your head to do the conversion, that's okay. The unit fraction is helpful, especially when you get to some unknown conversions, like some of the things that we'll deal with when we convert between US and metric. Those aren't as intuitive because we don't use those on a daily basis. So having this system in place is helpful when we get to some of those. So, all right, so here's another one. Convert 15,840 feet to miles. So I'm going to write down the amount that I'm starting with, which is in feet. I want to convert that to miles. I can put this over 1 if I want, if it helps me. So here's my unit fraction. Answer is going to be in miles. So I kind of get all that situated. Okay, so now I go to my conversion sheet and I see that 5,280 feet is equal to 1 mile. Okay, so I want to make sure that I put this so that feet cancels and I am left with miles. So I want to put feet on the bottom in this case. And 1 mile on top. So now I can see that feet are going to cancel out, right? Because I've got feet in the top and the bottom, and I'm going to be left with miles. And so I've got my units correct, right? I've got my unit fraction in the right order, so that's important. So now multiply the two fractions, so the numerators get multiplied, so that gives me 15,840 over 1 times 5,280, and then of course I would want to divide that. So you could use your calculator to divide, and we get 3. Okay, so that's the system that we're going to use to do conversions throughout the entire module. If you can get a good understanding of the system that's in place here with the unit fractions, making sure that you get the units in the right spot so that the ones that you want to get away from cancel, what you're going to is left, and then the rest is just multiplying fractions, doing the arithmetic. Get that system in place, and you're going to have all these conversions on your conversion sheet, right? I'm not going to ask you to memorize all of these. You can, like the top of this says, you can use this on the test, so don't lose it. All right, so you should be in a pretty good place. All right, let's look at another one. 15 inches to feet. So once again, 15 inches times the unit fraction. We want our answer to be in feet. Okay, so we know that there is 12 inches in a foot. So I'm going to put inches down here in the bottom so that inches cancel. So get my unit straight, I'm left with feet. So that's great. And I get 15 over 12. And of course I can divide that and get 1.25 feet. So 1 1/4 feet. And for these problems in my math lab, you certainly can have decimal answers, just look at the instructions if it will accept the decimal answer, and so this one was a decimal answer when I looked at it. So okay, so here is a somewhat of a different problem here. Got a weird glare on my paper from the sun, but I think you guys can still see it. So it says 19 feet equals how many yards and then how many feet. So this is a particular problem where a decimal answer would not be acceptable. They essentially want whole units in both yards and feet. So to do that, we want to use long division. So we are converting to yards initially, right? So we can still set up our unit fraction, 19 feet times our unit fraction going to yards. So we know that there is 3 feet in a yard, so the feet's going to go in the denominator, so that feet cancels and I'm left with yards. So I'm going to get 19 over 3, and of course if I divide that I'm going to get a decimal. And so here's the conundrum for this particular problem. We don't want a decimal, we want whole yards and whole feet. So we do long division. So we divide 3 into 19 using long division, right? And 3 is going to go into 19 6 times. And so that tells me the number of whole yards that I have, right? So I've got 6 yards, and then I multiply, subtract, and my remainder tells me how many feet I have left over. So I have 6 yards and 1 feet left over, and so that is the answer that we're looking for here, as opposed to a decimal answer. Okay. Okay. All right. Another problem here dealing with adding measurements. So 2 feet 6 inches plus 3 feet 11 inches. So you can add the units together that match. So we can add feet and feet, right? So 2 feet plus 3 feet is going to give me 5 feet. And then add the inches. 6 inches plus 11 inches is going to give me 17 inches. However, there's something wrong with that answer, right? And what's wrong with it is I have more than 12 inches here, so I can make another foot. So if you can convert some of these inches over to feet, you want to do that. So 12 of these inches can go over to make another foot. So then that makes it 6 feet, and then of course if I take 12 from the 17 here, then that's going to leave me with 5 inches left over. And this is the appropriate answer. So, and that makes sense, if you were going to the doctor and they measured how tall you were and they said you're 5 feet 13 inches tall. That wouldn't make a whole lot of sense. They would just tell you that you're 6 foot 1 inches tall, right? Because obviously 12 of those inches convert to a foot. So that's basically the same idea here. Okay. So most people are more familiar with working with the U.S. measurements of length, inches, feet, yards, miles, just because we use those on a daily basis. But the rest of the world uses the metric system, which is actually easier. The U.S. is only one of 3 countries in the entire world that still uses standard measurements It's like the U.S., Burma, and I forgot the other country. So the majority of the rest of the world uses the metric system for a good reason, and I'm going to show you right here. Alright, so if you look at the middle of your conversion here, and I don't having issues with my light here, trying to get this to show up good for you. Doesn't make it any better. Okay. Alright, so we'll go with it. Sorry about that. So I have given instructions here to help you with the metric system, and we're going to go through some examples here, but basically we're going to look at the middle of this this middle row, which is length. So this middle row here is length, so you might want to just make a note of that for future reference. And of course most people have worked with meters before, but you know, the middle row is length. Okay, so we've got meters in the middle, and then this is decimeters. So I've given you the prefix decimeters, dm, centimeters, cm, millimeters, mm, decameters is dam, hectometers is hm, and then kilometers is km. And so this basically goes largest unit of measurement, kilometers, to smallest unit of measurement, millimeters. So it goes from largest to smallest, left to right. Okay. And so what's nice about a metric system is I can basically just move a decimal. Everything in the metric system is base 10. So if I want to move from centimeters to meters, I literally just move the decimal to the left that many places based off of this scale. So if I'm going from centimeters to meters, that's 1, 2 places that I'm moving to the left. I just move the decimal 2 places to the left, because I moved 2 places to the left on this scale that I've given you. If I want to go the other direction, let's say if I want to go from hectometers to decimeters, right? Well, that's 1, 2, 3 places to the right, right? To go from hecto to deci, I just go 1, 2, 3, right? So I move the decimal that many times in the same direction. Okay. So there's no unit fractions, there's no multiplying, dividing, it's just literally moving a decimal left or right, which makes life a lot easier. So let's look at some examples here. So 1900 meters to kilometers. So let's first of all write 1900, right? And let's find where the decimal is. So, you know, if it's a whole number, the decimal's not going to be written, but it's still there. It is to the right of the last number in the whole number. So the decimal in 1900 is right there. Okay, so that's the first thing. Find the decimal. Okay. Next step, look at your metric system conversion sheet, right? And so find the unit that you're given. So we're given meters. So I'll put my finger there. And I'm trying to go to kilometers, which is right here, right? So how many places am I going to move my decimal? Well, I just count as I move along this scale from meters to kilometers. 1, 2, 3. So I'm going to move the decimal 3 places. 1, 2, 3. And I'm going to move that decimal to the left because I had to go to the left to get from meters to kilometers on this scale. So if I follow the scale, it tells me not only how many times to move the decimal, moving from one unit to the other here, but it also tells me the direction. So I want to move the decimal in 1900 3 places to the left. So I go back to my decimal here, move it 3 places to the left, 1, 2, 3, And so 1900 meters is equal to 1.9 kilometers. So that's all there is to it. So the metric system is very, very nice. Literally just moving a decimal around. So use the conversion sheet to help you out. That's why I've given all of this to you, so that you can utilize it. So, all right, let's look at another one. 37.4 millimeters to decimeters. So we are actually given the decimal here. Okay, so here's our decimal. So let's go to our scale. Let's find millimeters, which is here, right? And I'm trying to go to decimeters, which is right here. So that means to get there, I got to move 2 places to the left. 1, 2, right? So that means I'm going to move the decimal 2 places to the left as well. 1, 2. So I get 0.374 decimeters. All right. Most people, once they learn the metric system, actually prefer it. They realize how much easier it is. All right, so here's a problem. 39.3 millimeters minus 3.09 centimeters equals blank millimeters. So I want my answer in millimeters. Right, so that's important. So this is in millimeters, this is not, right? So essentially I need to convert this 3.09 to millimeters, and then I can just subtract. Okay, so let's go to our conversion. We're going from centimeters to millimeters, so I'm going to move the decimal 1 place to the right. Okay, so if I move the decimal 1 place to the right, I get 30.9 millimeters. And then now I can subtract those two. You can use your calculator if you wish. So 8.4 millimeters. So with those particular problems, just make sure you get all of the units the same, and make sure that they're all in the same unit that the answer should be in. Okay. Zoom out just a bit here. I wanted to show this problem because a lot of people end up asking me about it, so I figured I would try to just do it for everyone. So Jim is 6 foot 9 inches tall. Jane is 23.5 inches tall. How many times taller than Jane is Jim? So notice that Jane is in inches, and that is as a decimal. So I'd recommend getting both Jane and Jim in the same units. It's easier for me to convert Jim into inches, right? I know that 6 foot is going to be 6 times 12 inches, because there's 12 inches in a foot. So that's 72 inches for the 6 foot plus the 9 inches. So Jim is 81 inches. And Jane is 23.5 inches. So now they're both in inches. Okay, so to find out how many times taller than Jane is Jim, well, that's a division problem, right? I'm literally going to take Jim's height in inches, divide it by Jane's height in inches, and then that will tell me how many times taller. So 3.4 times taller. So think it throws people off when they see how many times taller than Jane is Jim. That sentence kind of throws people for a loop, but you're doing a division problem, right? So essentially, if I multiply 23.5 times 3.4, then I get 81. I get Jim's height. So, all right, here's another problem that students sometimes get confused about. A 3.87 meter long sash cord has become frayed at both ends, so that 2 centimeters is trimmed from each end. How long is the remaining cord? So, if you want to draw the sash cord, you could certainly do that. It's 3.87 meters. And I want to take off 2 centimeters, right? And the answer here needs to be in meters, according to the MyMathLab problem. So basically, I'm taking 2 centimeters off this end, and I'm taking 2 centimeters off this end, right? But if I want my answer in meters, then I need to figure out how many meters I'm taking off of each end, not centimeters. So once again, go back to your conversion sheet. All right, so to go from centimeters to meters, right? Here's centimeters. To go to centimeters to meters, I'm going to move the decimal 2 places to the left. All right. So two centimeters is equal to, here's the decimal in 2 places to the left, 1, 2. 2 centimeters is equal to 0.02 meters. So I'm taking 0.02 meters off of each end. So I'm taking 0.04 meters off. If I add both of those together, so basically 3.87 minus 0.04 should give me my answer of 3.83 meters. So just convert the centimeters to meters, that way everything's consistent, and then you can do the subtraction. Okay, hope you found this video helpful. If you have any questions whatsoever, please email or stop by office hours. Have a great day.